Extension 1 students, let's look at this very hard rate of change question from 2024 Sydney Boys High School. So let's read the question together first, and you can pause the video to look at the question if you want, and you can look at the link in the YouTube to see the full solution and the PDF. So the first one is just volume of revolution, and it's spinning a circle around the y-axis, and this one, it should be easy. Question B, it starts getting hard. The diagram below there is a coffee cup like this. Honestly, I've never seen a coffee cup like this in my life. The lower part is described like this, which is in part B, and the upper part is a frustum of a circular cone. So it's not a part of circular cone, the whole thing would be like this, but it cuts here to get this. Of height 8 centimeters, with the radius on the top cup is 6 centimeters. Now it's asking us to find the rate of increase when the coffee cup is 3 centimeters. The first two questions, they're quite easy, I would say. So the first one is literally just you plug in the formula for volume of revolution using the circle equation, and then you can get this result. And do not forget the units. If there's no unit, you write a u to the power of 3. Actually, should I do that? Should I do it or not? Yes, I should do that, because it says cube units. So the second one, because it says the depth is 3 centimeters, it haven't passed 4 centimeters. It's 4 centimeters here, 3 centimeters. So we can still use the first one. We use the chain rule to find the rate, and it's quite easy, so I won't elaborate. Now the third one, it's asking you to find the volume of the coffee cup when h is 4 to 12. This graph, it can be misleading. It is not h. So here is h equals to 4. So here is h equals to 12, and here h equals to 0. This particular length, it should be h minus 4 instead of h, which is a bit misleading. Now we're supposed to find this volume, and we are extension 1 students. The standard way is not the year 10 stuff we learned. It is not the 3D formulas we learned in year 10, such as the formula for prism. No, it's not. We use volume of revolution, and we draw a Cartesian plane like this. So in this case, we already know this part. Now we just need to know this part, revolving. Okay, so let's look at the method 1. This is what I said about being prone to careless mistake. Actually, this one, I think, is the paper maker's question. They didn't specify it. And V1, the bottom one, we can already calculate. We just need to find the V2. Now we use the volume of revolution, which is this, a straight line, and we know these 2 points, because if we draw the diagram, I know the radius is 5. I know here it's 3. So use I know this is 4. I know these 2. Using Pythagoras, I know this one. So I know that these coordinates, I can find the equation of the line, right? If I find the equation of the line, I can just chuck in this formula, and eventually I'll get this result. And I plus them together to get the result as required. Now, I think when I do the question, I couldn't do it because I established the Cartesian plane like this, because here it's like I thought h equals to 0. Here, I thought h equals to 0 because it says h, so I thought equals to 0. But if you do that theoretically, you'll get the same result. But it's hard to get it in the form of this. In the form of h plus 4, you'll get like h cubed or something, and you need to make it up, so it's impossible. So you need to recognize that the starting point is 4 rather than 0. Now, the last question, after the cup is filled. Okay, actually, we have another method for this question, which is using the volume of a cone. I wouldn't recommend it, but you can do it. I know this is 6. I know this is 6. I know this is 3. I know this is 8. So after I extend it, which is this? So it's a median line of the triangle, so this should be 8. And now I want to know this part. So here it's 3. Here it's 8, which I just calculated. This is h minus 4. It's not h. And this is r. So I use some trig ratios to find the expression for r and for h. Then I can basically find out this expression by finding the difference between the smaller cone, which is this cone, V3, and the larger cone, which is this cone. I minus them together to find out the V2, and then I just plus them together to get the whole volume. So this is the trick. It's not that hard. The trick is not that hard. It's only the notation that's a bit hard. Last one, after the top cup is fully filled, it cracks at the bottom, and the coffee leaks at a rate of this. So what's the rate of decrease after 15 seconds of leaking? It's another raised question, and this is very algebra heavy question, but it's not hard. So let's see how we do it. Obviously, we already have the result from the last question, and I always say if you can't do it, skip it and do the next question using the result they give you. They give you for a reason. First, to let you know that you got the true result, and also if you haven't done it, you can use the result they give you to do further questions allowed. So all leaked is this. So this is time This is like the rate of leaking, so you get the total leaked volume, and you just want to check if after leaking it's here or it's here, and you test this upper half volume. It's this, which is obviously greater than 30, so it's still up here, which means it's quite complicated. Now we have this result. We find the derivative here. Now if you can plug in H, you will get it, but what's H? You don't know. You only know it leaked this much, so you need to find out. Or originally it's like this, right? It's full, but after some time it's here. We know that this is 30, the volume is 30. We want to know the new height. So how do we do it? We can basically, we know the volume, and we use the relationship between V and H. We have the relationship. I know the volume, so I should know the H. I plug it in, and basically I find this expression for H. Now I need to plug it back, so I use what? I put the power of 2/3 on both sides to get this, and I plug it back in to get this. And again, I made the careless mistakes of not writing the units, which of course I left it there to see if you guys notice it or not, as all teachers does. And I actually made a lot of careless mistakes here. I just consistently get the wrong result. And why is that? Because when I copy it down, I was so focused on these two that I forget there's a 3 here. So when I copy it, I literally forget this, and then I got the wrong result. So I wrote it here. I made exact careless mistake 3 times, because when I'm copying it down, I forgot the prime. So it's important to not copy things wrong, or you can just approximate it earlier. It doesn't matter. And everyone makes different types of careless mistakes, and once you identify it, you can know when next time you're doing it, you can think of it. Oh, I might make careless mistakes here, so I'll be extra careful. Then you can avoid it. And this one, I reiterated a lot of times. It's basically the definition problem. It's a flaw in this question, and it's why this question is a bit tricky. And again, subscribe and like if you enjoyed this video, and follow along for more HSC math videos for Extension 1 and Extension 2 students.